I'm going to talk about two of the homework problems here. They both have the same idea, but one of them is a little more complicated and it requires you to think outside of quadrant one. So let's talk about quadrant one in this first example. It tells me I have a point, 11, 10. It's in the standard coordinate plane. Okay, so it's going to, here's my picture. I've got a standard coordinate, that's terrible. Hold on, let's try to do this a little better. I've got a standard coordinate plane with straight axes like this, and I have a point 11, 10. So what is that? That's like 11 over, I'm going to use red here. It's like 11 over and 10 up. It is not important to be accurate in these triangles. Just draw yourself a triangle. That's like always step one in these trig problems. Draw yourself a triangle and try to put the axes in the right places. That will help. 11, 10, and that gets me to this point on the terminal side of an angle theta. So here's my angle theta. The terminal side is the hypotenuse, and this point right here is 11, 10. Okay, so I have almost drawn a complete triangle picture. What's missing? Well, it's the hypotenuse. And we know Pythagorean's theorem. That tells us that h squared equals 10 squared plus 11 squared, which is just 100 plus 121. So that means h is the square root of 221. Okay, so we can put that right here. Square root of 221. Now we have a complete triangle, and the rest of this problem is going to be a snap. So what is sine of theta? Okay, well, sine of theta, if you remember, is just opposite over hypotenuse. So this becomes 10 divided by the square root of 221. Okay, likewise, cosine is going to be 11 divided by the square root of 221. And the tangent would be 10 over, where's tangent? Here we are. 10 over 11, opposite over adjacent. And those other functions, cotangent, secant, cosecant, we've been over those a bunch of times. Those are just your reciprocal functions. Now, let's talk about the second part down here. If you look at this guy, what's different? Well, the point is different. Let's draw ourselves a coordinate plane and see if we can figure this out. So -9, -7. Well, let's draw a triangle to use here. -9 is like, I don't know, over there. -7, a little way down like this. So here's my triangle. And you can see that that coordinate point right here pointed me to a place in the third quadrant. Okay, so let's get that coordinate point there. -9, -7. X is -9. Okay, so that means that's X. And this is Y. Okay, so to complete this triangle, I need the Pythagorean theorem again. H squared, I'm going to call this H over here. H squared equals -7 squared. Don't worry about those negatives. -9 squared. And now what happens is those negatives become positives when you square them. That's what negatives do. And -49 plus 81, math, 130. Okay, which means h is the square root of 130. I'm going to put that on my picture right here. The square root of 130. And now, just like before, we just figure out what the sine, cosine, etc. is. So I'll start with sine. Okay, that one's, we know that. Sine of theta equals opposite over hypotenuse. So let me just draw theta for a moment. And this is where people often get stuck too. Let's say, here's theta. Okay, great. It goes all the way over to the terminal side. What is the opposite of that angle? Doesn't make any sense. Theta is obviously not in a triangle. I drew a red triangle over here, but it doesn't contain theta. Theta just points to the terminal side, the hypotenuse. So what I want you guys thinking about is not so much theta, but the reference angle. Remember I said in one of the previous videos, reference angles are going to be really important? Here's my reference angle. And I'm going to tell you that sine of theta is equal to sine of the reference angle. That's why reference angles are so useful. So the sine of the reference angle is opposite over hypotenuse, which is just going to be, let's see, -7, the opposite of that blue angle there, the reference angle, divided by the hypotenuse of square root of 130. Okay, so that would be your answer for sine of theta. Can I fit this in here? Negative 7 over that square root of 130. Okay, I didn't do secants and cosecants in the last example, but you know, those are actually even easier because you just take sine and you flip it over upside downy and make it into cosecant. Remember, these are reciprocal functions. So the cosecant would be square root of 130 divided by negative 7. Just literally flip the fraction upside down. Now you can leave your answer this way. It's not simplified, right? I might be able to pull something out of that radical. I'm not sure. There's a negative on the bottom that looks ugly, but for the most part, these answers don't care if you leave your fraction ugly. They just care if you get your fraction right, because that tells me you understand how reference angles work, how to build triangles in the coordinate plane, and how to use the basic SOHCAHTOA properties and reference angles to figure out the trig functions.